Hello, and today I will talk about differentiation. So, what is a differentiation? Differentiation is the process of finding the derivative of a function. It also represents the instantaneous rate of change of a function with respect to a variable. Here we have the example of differentiation, which is dy over dx equal limit h approaches 0 fx plus h minus fx over h. This is also known as the first principle or limit definition. It also represents the gradient of the tangent line to a curve at a point. Now, the importance of differentiation. Differentiation determines the rate of change, finds the gradient of a curve, determines maximum and minimum values. It can also be used in real-life applications such as velocity and acceleration. Next, we have 6 techniques of differentiation. For the first one, we have power rule, and then we have product rule, quotient rule, chain rule, trigonometric functions, and logarithmic and exponential functions.
For the question 2, which the question asks to find dy over dx for the following function. The function is y equals to ln x power of 2 plus 1 and cos x plus 1. We can see here, inside this equation, we got two functions, so we need to use product rule. For the formula for the product rule is d over dx uv equals to u v prime plus v u prime. From the function, we need to separate it. For u, we use ln x power of 2 plus 1, and for v, we use cos x plus 1. After we differentiate each function, we will get the value. Like the u, we will get 2x over x power of 2 plus 1, and for the function that we use for v, after we differentiate it, we will get negative sin x plus 1, and using those value, we need to substitute all of them into the product rule. And we can see here, after we insert it, we will get dy dx equals to ln x power of 2 plus 1 negative sin x plus 1 plus cos x plus 1 multiple with 2x over x2 plus 1 x power of 2 plus 1, and we need to simplify all of them, and the final answer we will get negative ln x power of 2 plus 1 sin x plus 1 plus 2x cos x plus 1 x power of 2 plus 1.
Next, for question 2b, we are given the function y equals tan of 4x divided by 1 plus x squared. Since this is a division of two functions, we use the quotient rule. The quotient rule is vu prime minus uv prime over v squared. Now we're gonna identify which is u and which is v. Let u equals tan 4x and v equals 1 plus x squared. First, we differentiate u. The derivative of tan 4x is secant square 4x, and we apply the chain rule, so we multiply by 4. So du over dx is equals to 4 secant square 4x. Next, we differentiate v. The derivative of 1 plus x square is 2x. Now we substitute into the quotient rule formula. So dy over dx equals v times du over dx minus u times dv over dx, all divided by a square. After substitution, we get dy over dx equal 1 plus x squared times 4 secant square 4x minus 2x tan 4x divided by 1 plus x squared square. So the final answer is dy over dx equals 4 times 1 plus x squared secant square 4x minus 2x tan 4x over 1 plus x square square.
We need to find dy over dx using implicit differentiation for ln y plus cos x power of 2 plus e power of y equal to 2xy power of 2. So the first step is we need to differentiate both sides. So starting on the left, we are going to use formula derivative of logarithm and trigonometric function, also chain rule. This is what we are going to get, 1 over y dy over dx negative sin, and using the chain rule we are getting 2x plus ey dy over dx. Next, on the right, 2xy power of 2. This is actually two terms, so we are going to use product rule and power rule for differentiate. Following the product rule, we are getting u equal to 2x and v y power of 2. With power rule, we are getting u prime, which is 2, and v prime, which is 2y. Following the product rule, we are going to write our equation like this, expand it, and we are getting like this. Finishing left and right, merge it, and this is what we are going to get. Finishing the step 1. Step 2, expand. We are going to expand negative sign using distributive law. So our a, b, c will be negative sign x power of 2 plus e power of y, b 2x, and c e power of y dy over dx. So this is how we are going to write our equation, expand it, and this is what we are going to get. Also, don't forget to merge it after finish. Next, for the third step, we need to separate equation with dy over dx into the left side and move everything that doesn't have dy over dx to the right. So for the fourth step, factorize the equation, and this is what we are going to get. And 5, move the factorized equation to the right. We are going to get fraction, and this is also our final answer. That's all. Thank you.
Okay, for the final question, for question 4, we need to use linear approximation to estimate the value of 8.02 square minus 1 over cube root of 8.02, correct to 4 decimal places. Step 1, we define the function. The function is x square minus 1 over cube root of x. Then we rewrite it in index form as x square minus x power negative 1 over 3. Step 2, we differentiate the function. The derivative of x square is 2x. The derivative of negative x power negative 1 over 3 becomes positive 1 over 3x power negative 4 over 3. So f prime of x equal 2x plus 1 over 3x power negative 4 over 3. Step 3, we define the values. X is 8.02 and x naught is 8. So delta x equals 8.02 minus 8, which is 0.02. Step 4, we write the formula. F of x naught plus delta x is approximately equals to f of x naught plus f prime of x naught times delta x. Step 5, we substitute into the formula. F of 8.02 is approximately equals to f of 8 plus f prime of 8 times 0.02. Step 6, we find f of 8. F of 8 equals x square minus 8 power negative 1 over 3. This gives 64 minus 1 over 2, so f of 8 equals 63.5. Step 7, we find f prime of 8. F prime of 8 equals 2 times 8 plus 1 over 3 times 8 power negative 4 over 3. This gives 16 plus 1 over 48. So f prime of 8 equals 769 over 48. Step 8, we substitute the value. F of 8.02 is approximately equals to 63.5 plus 769 over 48 times 0.02. After calculation, we get 63.8204178. Therefore, correct to 4 decimal places, the final answer is 63.8204.
In conclusion, differentiation determines the rate of change of a function. Differentiation can also be used to find the gradient of a curve. These techniques can be applied by using power rule, product rule, quotient rule, or chain rule. Differentiation is also used in derivative and linear approximation. That is all. Thank you.